the Metasploit team altogether. So with that in mind, there are a whole bunch of things that I want to talk about. They're not necessarily related, so the transitions are going to be a little bit rough. This is a grab bag. And when you search on Google Images for grab bag, this is the most fucked up thing I could find. So first I want to talk about some infrastructure stuff. In the last 12 months or so, a lot of things have changed. We've got GitHub now as our primary distribution mechanism. All of our installers have become much more streamlined. We've got stable update mechanisms. So all of this infrastructure thing are important for sort of the whole ecosystem of Metasploit. It's not necessarily some cool technique that you'll be able to use, but it's still important for how you get Metasploit, how you take advantage of some of these new cool things. The first is SVN. We've gotten rid of completely the Subversion server that we used to use. And for those of you playing at home, this is the Tacoma Narrows Bridge, because that's the kind of infrastructure SVN provides. If it gets really windy, it just falls over. But now it's dead. The server that we were using was constantly getting DDoSed because it's Metasploit and script kiddies hate Metasploit. So we were constantly getting like packeted from the Ukraine and that sort of crap, which occasionally led to hilarious results, like HD turning a botnet back around on the command and control server that was controlling it. But it was a constant headache for us. It was a constant maintenance nightmare. And some of these DDoSes were actually just dumb things. Quite frequently, we would get like Baidu scraper would come by and try to index 500,000 lines of code with recursive links. And so it would just sit there and make millions of requests an hour, which is not great for our infrastructure. So sometimes it's not really assholes DDoSing us, sometimes it's legitimate things just being stupid, but nevertheless, we didn't want to have to deal with that anymore. And Subversion requires a different request for every new file. So if we made a big change, like if we made some change that had to touch every module, when you do an update, you would have to make a new request, a new TCP connection to get every single file that changed. And that's kind of retarded. So when we did a big change like that, it was impossible to get all this stuff quickly, and people would frequently have just straight up timeouts and their updates wouldn't work. So I'm really glad that that's gone. Now everything is 100% on GitHub, which has 99% uptime. They said someone said 5 nines, but it's more like 2.5. But now SVN is completely gone. You can get everything from GitHub. You can get all the download all the installers from Metasploit.com. It's all much smoother, much easier to deal with, and MSF Update does it all. Whatever kind of installation you're on, MSF Update deals with it. We also have stable updates, which for any of you who have done demos on master branch or the old SVN trunk, stable trunk, you know that when you want to do a demo with Metasploit, the worst possible thing you can do is run SVN up right before you get on stage. Fucking terrible idea. Now we have stable updates. We've gotten rid of some of that problem. We do updates about once a week, and everything is sort of streamlined so that you're less likely to have a completely broken framework at any given time. We still have the master branch, which should theoretically not break, but occasionally I still do something stupid. We've guarded that quite a bit now, and it's a lot less frequent. So the master branch is a hell of a lot more stable than it used to be, but it's still bleeding edge. It still sometimes breaks. Our stable updates are fairly stable. They're QA'd all the time. And we do a stable update about once a week that should work for you most of the time. So next section is exploitation stuff. That's all the infrastructure, all the things that help you get Metasploit, help you run Metasploit. This is how you get shells with Metasploit. And one of the most fun things that I've seen is SAP. And Chris John Riley did a whole bunch of cool stuff with SAP in 2011. He did a great talk at Hash Days in that year with a bunch of cool techniques for getting ridiculous amounts of information from SAP systems. And SAP systems are the kind of things where it's not, SAP doesn't store a credit card, it stores all the credit cards. It doesn't store a user, it stores all the users. It's ridiculous amounts of information all in one place. So that's sort of the background. Chris John Riley did a bunch of stuff there. He wrote a whole bunch of auxiliary modules for scanning that kind of crap around that same time. Then Mariano Nunez of MWR InfoSecurity dropped a thing called BizSploit, which was for SAP business systems or business objects or whatever it is. And that was really useful for what it did. But I like everything to be in Metasploit because Metasploit is your one-stop shop for how to get shells everywhere. Oh, you are a good man, sir. Oh shit, you got two of them? Oh, it's cheering. Okay, there we go. Ah, thought you were gonna make me double fist. Faderade for the win. So then this guy NMonkey came along, and he said, "That's great and all, but all of this stuff is unauthenticated, and we can get a whole bunch of information from it. But what else can we do?" And with BizSploit, porting some of the things available from BizSploit and adding some of his own stuff, he put it all together, added on to some of the things that Chris John Riley did, and we end up with now you can scan an entire network for all of the things that run SAP, use that to pull out all sorts of like SNMP stuff. There's all sorts of information in there. Sometimes you get usernames, sometimes you can even get passwords from that information. Once you've got those, if you can log into an SAP system, there's even more stuff there. There are intentional, by design, pieces of SAP that allow you to execute operating system commands. So once you've got Creds, you can just run whatever you want on that system. But one of the things that NMonkey pulled out that no one else had really talked about before was there's a thing called SAPRouter. And it does kind of what you might think something of that name might do. It allows you to route packets, which awesome. So one of the things you can do with that is you can tell the system to go get a file and use that as the configuration or whatever. But because if it's a Windows system, files can be UNC paths, you can tell the SAP system to go get this file. It's a UNC path that points back to your box. Now you can convince that SAP system to authenticate to you. And that's all manner of stupid. SMP relay, for anyone who's unaware, basically allows you to take an NTLM authentication and pass it from the guy who's authenticating it to you to someone else that you want to authenticate to. And anything that's running an SAP server is probably going to be a local admin somewhere else on the network. So you can SMB relay all over the place with that stuff. The next bit is using that same sort of idea with SAPRouter. You can also, using Metasploit, set it as a proxy. It's got this SAP ni_route subcommand within the protocol, and it basically just says, hey, I want you to act like a firewall. I'm going to send you packets, and I need you to route them to this guy, wherever I tell you to send them to. So you can make arbitrary TCP connections from that box and have it go anywhere else on the network that it can talk to. Amazingly cool stuff. So to use that in Metasploit, it's just this one command. And now anything anything that can use a Metasploit proxy will be able to run through that system. Very, very cool. So the next little bit is upnp. Is anyone in the room familiar with upnp? What it can do? Well, maybe that guy. This is all HD Moore's research. upnp is amazing. It gives you all kinds of retarded access with no authentication. You can open up firewall holes. You can do all kinds of stupid stuff. A lot of devices actually allow upnp from the internet, and HD did a big O scan of the entire internet, like you do, and found, what was it, 80 million devices, so roughly 80 million devices allow upnp from the internet. So you can talk to a upnp server on the internet and say, hey, Mr. Firewall, I would like you to open up a hole so that I can talk to the outside, which is really the inside, and now I can open up firewall holes that go through wherever your network is. Awesome, awesome stuff. All of these boxes are something that's been sitting there forever. They're mostly ancient. They're mostly little embedded devices that have never been updated. Somebody dropped them on the network and forgot about them 15 years ago. So old systems with amazingly awesome capabilities. And they pretty much all use one of a couple of libraries to deal with this. One is libupnp. It's the main one that most things use. It's the Intel portable SDK for upnp devices. HD has a whole bunch more information about this. He's talked about it elsewhere. It's all super awesome. But my favorite bit is the vulns that he found. This is actual libupnp code. It takes a buffer on this is a stack buffer, a thing called pointer1, a thing called pointer3, and a thing called pointer1, and it, like, who names variables like this? This guy, like, clearly is an asshole. Anyway, pointer1 is something we control. Guess what? Pointer3 is something we also control. And oh, by the way, we still control pointer1. So arbitrary stir copy, and as we learned in Corlan a couple of days ago, stir copy don't care. Stir copy's like honey badger. Stir copy don't give a fuck. The next coolest part about this, like, this is a pretty cool part because that's retarded code. But the next best thing is that you can trigger this piece of code, you can trigger this overflow with one spoofed UDP packet that you could spam across the entire internet. Like, it's one spoofed UDP packet, so you could make it look like it's coming from China. Who cares? Yeah. Yeah, 7 vulns in one function. That's special. So then there's this other thing that HD did called IPMI, which is the Intelligent Platform Management Interface. Dan Farmer did some more research on this too. HDM was working on top of that. It's a protocol that basically allows you to control the motherboard of a big server, basically. The spec requires that it stores the clear text password. Like, the way that the authentication works, it must store the clear text password to be able to authenticate. So if you own one of these things, you get all the passwords. Super awesome. There's also a design level auth bypass. If you use the special cipher 0, that means don't encrypt anything and don't bother authenticating either. Just let me do whatever I want. So awesome. So that led to this exploit, which is a remote root on a little thing called a supermicro BMC, which is the thing that runs on the motherboard. And it always runs as long as the box is plugged in. If you power down the server, it's still running, still listening for packets. So yeah. So power the thing off, and then I can still send it as one spoofed UDP packet that owns the box. The particular technique that HDM used to exploit this was an old school predecessor to return-oriented programming called ret2libc. So for the youngins in the crowd, this is where ROP came from. You basically, instead of trying to figure out all the little pieces of code within that executable that you need to run arbitrary code, you just create a command that you want to run and you return to system. And then you don't have to worry about so many offsets and having to find all the things that you need, and you just get shell. And that's what it's all about, right? So now we get remote root on this little thing running on a motherboard that you didn't even know was there, and there are 80 million of them on the internet. So moving on from HD's research, there's another contributor named Michael Messner, who got really angry with home routers, I guess. And the result of that was 14 separate exploits, code execution exploits for a bunch of home routers, so D-Link and Netgear and all kinds of stuff. And you know, sometimes you think of a home router and you think, who cares about a home router? You know, I'm going to own your grandma. Who cares? But the thing that you don't consider is that your CEO also has a home router, and he goes home sometimes with the company laptop. So that suddenly becomes a lot more interesting. Also, over the last year, the light cosine and several other people have talked about WinRM and WinRS as well, but light cosine did a bunch of work on turning it into very simple code execution. WinRM is Windows Remote Management, WinRS is Windows Remote Shell, and who doesn't love remote shells, right? It does exactly what it sounds like it does. If you've got a username and password, you can manage the server, which means creating services, starting services, all of the normal things that you would need to do when you're managing a server. It also includes being able to run arbitrary commands. Windows Remote Shell is a remote shell. It's awesome. The idea of PsExec creating a service, dropping an executable, it's great. It's awesome. I love PsExec. But with WinRM, there's no need for any of that forensics evidence. Another little piece of awesome that Mubix dropped yesterday is, Mubix and Chris Gates, is the fact that if you have WinRM running on an IIS box, instead of running on some high port that you might not be able to talk to, now WinRM listens on port 80. Yeah. So if you've got IIS running on a server that has WinRM enabled, you have that server sitting in the DMZ, anyone who can authenticate to that server has complete control of that server. It's like you're running SMB on the outside. So what could go wrong, right? There's a couple of new cool little mixins. I said that none of this was my research. This particular one actually was mostly me. But it's very simple. It just adds some convenience methods for dropping executables if you're running as arbitrary PHP code execution. So if you've got some WordPress Vuln, you can use this mixin to simplify your exploit creation process. It'll drop an executable if your target says it's something that runs executables. So if your target says Windows x86, you can drop a Windows x86 executable. If it says Linux PPC, you can drop a Linux PPC executable, because why not? And using PHP, we can also arbitrarily unlink things when it's done. So that won't work on Windows, but it'll work basically everywhere else, and we reduce our forensics footprint. It's basically just a simple wrapper for making PHP code execution vulnerabilities more useful. FileDropper is another cool little thing in the same vein, where you've got some exploit that lets you drop a file, so some arbitrary file upload, web application, something along those lines. where you can drop a file, but you don't want it to stick around forever. You want to clean up when you're done. FileDropper makes it easy for your exploit to clean up after itself when it's done. You just register this file for cleanup, and by the time you get your shell, that file is now gone. It works for exploits and for post modules. It's a simple mix-in. As long as your module defines some way to execute commands, then FileDropper will be able to delete your thing. And it doesn't matter what operating system it's on. It works on Windows, it works on Linux, it works anywhere that you can delete a file with a command. So all of that is fun stuff with mix-ins and old school exploitation. In modern browser exploitation, a lot of things have changed. You can no longer just arbitrarily jump into a static stack buffer. That doesn't work. Pop-rets are a lot less useful. We need more power. We need more cool things. Heap spraying, the idea has been around for a long time. Corland Coder, who's awesome and sitting in the front row, did a bunch of cool research on spraying the heap with C button elements. So instead of using the sort of old school technique of just spraying with strings, just creating arbitrarily long strings and allocating as many as you can, if you use a button element, now it works super fast, super reliable, all over the place. It's fast and easy, and you can use it in any new browser exploit with just a single include. Super awesome. Also this year, as our Vuln landscape changes, ROPDB became very important. For when you're trying to find certain gadgets in memory, you need some way to find the things that you need. Mona provides a lot of that, and you can get a lot of what you need just from Mona and a debugger, but it sucks having to do that every time. So the ROPDB is designed to be a location for, or sort of a repository for all of the full working generic ROP chains necessary for executing code in XYZ, whatever executable you're working with. If ROPDB has a chain for it, then you don't have to look it up. It's much easier. As I said, the memory corruption landscape has changed dramatically in the last several years. There are a lot of old systems still out there, and sometimes an exploit that doesn't bypass ASLR, doesn't bypass step, sometimes it'll still work, but not really. If you want a reliable exploit in the modern world, you must bypass these modern things. You often need 3 whole exploits for getting full code execution. You need a memory leak to figure out where you live in memory, so you need an ASLR bypass. You need some corruption vuln, use after free or whatever, and then you need a sandbox escape. So that means you have to chain exploits. You can't just do it all in one simple piece like we used to be able to. And we've also got automatic no user interaction updates. That's a big problem too. So browser exploits, basically ODay is the only thing that matters in a lot of ways, which is kind of a bummer for us most of the time because everybody loves shells. But the point of Metasploit is to simplify this whole process. We've got the ROPDB, we've got multiple ways of spraying the heap, we've got various ways of chaining exploits so that you can do the sandbox escapes. So for example, I talked last year about privilege escalation. We've now got several Windows kernel vulnerabilities in the framework as well. So if you pop IE9 on Windows 7 and you're stuck in a low integrity process, you're screwed. You don't have access to anything. But if you can use Tavis's flatten rec vuln, Now you get ring 3 code execution. You go from a low integrity process that you can't do anything in, now you're running as root. So despite all that stuff, there's been a boatload of browser 0-day this year. Lots and lots of it. We had a whole bunch come out at Pwn2Own. We had a bunch of targeted attacks, which I thought was interesting. One of the scariest, I thought, was the anti-persistent threat of the FBI 0-day for Tor. They used a Firefox 0-day on the Tor browser bundle, and the payload did absolutely nothing but de-anonymize the client. That's pretty hardcore. There were at least 3 IE 0-days in the wild, which is pretty amazing considering how much effort is required to get a full working IE exploit these days. There was at least 1 Flash 0-day in the wild. So despite all of these pressures, all of these difficulties in creating new exploits, we still saw a whole bunch of them, which I think is interesting. There were also a whole bunch of Java 0-days. So many, in fact, that Oracle basically disabled it. They're like, fuck it. Click to play. It's just too dangerous for you to be running Java, so it's running on 8 billion devices, but we're just not going to let you do that. Well, okay, I guess that's fine, but you basically, because of click to play, they've made it so that every Java applet is equivalent to a signed applet for the user's perspective. The user goes to a web page, they see a thing pop up, and it says, do you want to run this? They click OK. It's exactly the same user experience. So now, in my opinion, unless you've got a click-to-play bypass, you might as well just be sending a signed applet. Because signed applet will always work. It doesn't matter what their version is. It doesn't matter whether they're vulnerable to the particular thing you've got. Signed applet will always work. And if they still have to, if they have to click something anyway, then you might as well just go ahead and get an actual shell regardless of their version. So signed applet is awesome. And if you can get a code signing cert and sign it yourself instead of using a self-signed cert from Metasploit, it looks even better than the standard click-to-play thing. The standard click-to-play thing looks kind of scary. The one with a signed applet looks kind of scary. It's got the word security in it. There's a little like danger icon. Like it's, I don't know. I'm scared. A signed applet with a trusted code signing cert, it's pretty. It's blue. It's calming. People like clicking yes when they see the pretty blue. So Java signed applets are still awesome. So all of that's about exploitation. Now I want to talk about some payloads. We've got several new repositories. This is more kind of infrastructure stuff. We broke out Meterpreter and Metasploit Java Payload into their own repositories. So Metasploit Java Payload also includes Android Meterpreter, which we'll talk about more later. But the idea is that if we can keep these things separate and buildable all on their own, it's A, easier for me to maintain, and B, easier for you to contribute. So if you want to write some Java, it's easier to just go to the Java repository and type Maven and do it. If you want to write some C, it's easier for you to go to the Meterpreter repository and write it there, and all of the build process is all still there, instead of being in part of the Ruby source where it doesn't really fit. So it's easier to build, it's easier to maintain, and very importantly, it's easier to test. So having them in separate repositories makes it a lot easier for us to maintain quality, and I think that's really important. There were also a couple of OS X x64 payloads. My favorite is Say, which calls the Say payload or the Say executable. So you can have your payload talk to the user and tell them that they're owned. Fun stuff. There were several other payloads there too, and some of these were written by our UI developer, which I think is awesome. Also awk, which lol awk. It's a text processing utility written by the GNU project or maintained by the GNU project. And they really like to extend things. So one of the things they extended in awk was giving it a full TCP API. So you can create servers, you can create connections. So you can make a full like web server out of awk, because why not? So now we've got payloads for awk. So we've got a full shell payload or reverse TCP and a bind TCP in awk, and I think that's hilarious. We've also got Ruby payloads, specifically created for the 2 vulns that came out for Rails. And I think these were somewhat hyped at the time because they were amazingly useful. Rails basically didn't have any generic code execution vulnerabilities up to this point, and with the discovery of these things, suddenly Rails became an awesome target. And because of them, now we've got Ruby payloads, so you can run arbitrary Ruby as a payload once it gets up to the target. Really lots of good times to be had there. Android Meterpreter, I mentioned it briefly before. It's still kind of in a proof of concept stage, so it's PhpEXE. It requires you to have an APK installation. Yeah, it was a good one. It requires you to have an APK installation, so it's still not really easily deployable. You have to have physical access to the device or ADB so that you can push it up. But it's still awesome. It's a lot of fun. Most of the features work. You can tunnel traffic through it. You can manipulate files. You can upload and download things. You can run commands. Pivoting is the most fun part, though. So you own a phone and you have it sleep for a while, and then when it gets on Wi-Fi, you have it call back, and that could be all manner of fun. So now I just want to quickly show some of that. You still hear me here? Okay, so this, is that even remotely visible? There, okay. All right, this is a Nexus 7. Hey, stop. Go. Home. Home. And the demo gods are not being nice to me. Okay, here we are. So, like I said, you have to install an APK. So it's got this kind of janky thing where you have to open the application. And then, hey, look at that. And then, here's my shell. All we did was open the application. God damn it. Mouses are hard. There we go. That's probably also not visible. And I can't see it over there. There. So now we've got a shell. We're running on a standard Android platform. We can do this. We can say ID. We get a bunch of crazy bullshit because it's Android and they've got a different user for everybody. But then we can also do like PM list packages. And that's all the packages on the system. Lots of fun. Is that useful? All because you clicked something. There we go. So now, Python Meterpreter. We've got PHP Java, standard old reliable Windows. Now we've also got Python. Python gives you so much. And I don't normally say that kind of thing because Python. But having a Python payload means that we can work everywhere that Python works. Now we've got a reliable Meterpreter that works on, I don't know, DDWRT or any kind of Linux that you can find. Python is now in the Linux standard base, which means every distribution is going to have Python. Even a lot of embedded ones are going to have Python. So having the ability to run all of your attacks through a Linux box or an OpenBSD box will give you a great deal of power going forward. It's based on PHP, but don't judge. The PHP code sucks, and this sucks less. There are a lot of really difficult things to overcome in PHP, and Python isn't that stupid. So I'm hoping that by the time this is all said and done, we'll have a very reliable, very readable, very extendable Python Meterpreter. And all of this was made possible by Zero Steiner, who's been amazing, and I really appreciate it. And that's Monty Python's Silly Walks, in case you didn't get the reference. Next fun thing is authenticated Windows proxies. So if you've got a proxy set up in IE, it's stored as the system proxy. In some cases you can get that out, in some cases you can't, but in a lot of times you've got creds and you know that you can get out if you can use those creds. Reverse HTTPS proxy will let you give it a username and password. So now you don't have to rely on the system at all. If you pop something else and you get a username and password that you know will work through the proxy, you win. This will let you out anywhere. Awesome. Mimikatz. Anyone in here familiar with Mimikatz? Raise some hands. Yeah. Mimikatz is awesome. It's an in-memory password stealer, and that's so cool. You get plain text creds for all sorts of things. Mostly, the most hyped one has been WDigest, which gives you plain text AD creds. Super, super useful. Very awesome. But less well-known in Mimikatz are the other packages that it can do, one of which is Live SSP. So if you've got a Windows 8 box, your login is tied to live.com. So if you pop a machine, like a Windows 8 machine, you use Mimikatz to get the Live SSP creds, that's also their Hotmail account. So this is really simple. Actually, I probably don't have quite enough time for this. I'll do it anyway. I'll do it quick. So very simple. You can see we're administrator here. This is an x64 Windows machine. And all we do is load Mimikatz and then run the wdigest command. You get a bunch of garbage, but you also get plain text passwords. So awesome. There's more fun new Meterpreter API stuff, including a netstat and an ARP command that does exactly what it sounds like it does. But now you can do it without having to drop to a shell. Netstat gives you all of the TCP and UDP connections on the system. ARP gives you the full ARP cache, which is very, very useful. All kinds of fun things can happen from that. Something that went in last week is victim-side DNS resolution. So if you want to find out where the DC is, you just say, hey, where's the DC? And it'll tell you. There's been a bunch of general Meterpreter improvements in the last month or so. We've got a new guy working hard on improving the reliability and the maintainability of Meterpreter. Everything has been updated to Visual Studio 2012, which will work in Express or the paid version. There's one command to build the whole thing, so all you have to do is install VS, open up a shell, and say make, and it works. Awesome. So much easier than the giant headache that it used to be to compile Meterpreter. Now it's so much easier to build. We've also fixed a number of bugs. There was a really fun one with reflective DLL injection, where there was a pointer that was defined as an int. So on x64 systems, most of the time that's actually fine because the top the top bits are not being used. But in some cases, some executables map that address or map at a higher address, and then this truncation would cause them to fail. So very simple fix, but now migration is reliable on x64 systems everywhere. Super awesome. Reverse HTTPS now also works on x86 and x64, and Sniffer no longer crashes on x64. So we went from a little bit shaky on x64 to completely solid in about a month. So super excited about the work going on there. That was all exploitation. A new command stager for when you've got some exploit that gives you command execution. If it's bash or whatever, you can use echo-ne to write arbitrary bytes to the file system wherever you want. Gives you a way to bypass size restrictions, bypass character restrictions, having another arsenal or another tool in the arsenal to get around those kinds of restrictions. Better encoding for BinSH payloads as well. So there's more edge cases where you can't use this character, you can't use that character, it has to be this length. So our BinSH encoder is a little smarter now as well. Stage encoding is highly underrated. It makes network IDS have to work for their living. Instead of seeing the second stage come across as just a giant blob of Meterpreter DLL that looks really easy to fingerprint, now it's katanakanai, bitches. So everything looks random, and it's a lot harder to fingerprint things on the wire. So stage encoding is super useful. You can also use database credentials in all of the AuthBrute modules. Anything that takes any of the auxiliary brute things, there's the telnet login, the SSH login, all of those. Now you can just use the database credentials all directly from there. It's super awesome. Any questions? I told you it was a grab bag. It was all kind of disjointed. So if any of this comes back to you later and you're interested in talking about some of it, hit me up on Twitter, send me an email. I'm always in pound Metasploit on Freenode, so talk to me on IRC. And the next craziest picture I saw while searching for things for this is that one. Yeah. All right. Any questions? Oh. Thank you. Oh, fun. Okay, so the comment was that Oracle has announced that they're going to be turning off unsigned, or self-signed or unsigned? Oh my. Turning off unsigned and self-signed applets altogether. Wow. So they're really... Okay. I guess you need to spend the $100 for a cert so you can own everybody now. Right. Any other questions, comments? All right, thanks for coming.